All right, so let me get my calculator out. Everybody go to that page right there. Okay. All right, so let me get my calculator. I'm trying to pull it up. We've already done these problems, so that's my son.
You got it up with it.
Okay, there it is. Okay, here we go. All right, so remember, this is Unit 4, okay? Unit 4. All right, so focus. We're going to finish Unit 4. We're going to be done with Unit 5. And that's it.
Unit 4.
Okay. Unit 5 will start probably after New Year's. So, yeah. We're going to hope. You guys are doing a great job. We're going to finish very, very big time before Thanksgiving. Okay? Which will be good because that'll leave you have that week off of Thanksgiving. You kids come back, and you should just be focusing on if you're behind in this class, then that's the only thing where you would try to worry about. But nobody is behind right now. Everybody's on task. Well, I'm going to try to see if there's going to be a way maybe I can start a second semester class early if I finish early. But the time change and it'd be a mixture of all my other classes together. And maybe we could start second semester and just keep moving on until before Christmas break when we're 2 weeks off again.
Can you help us finish up?
Can't help some people finish faster if I can. I don't know if I can do that. All right, so here we go. I already did sohcahtoa, but do me a favor. You gotta get in the habit of writing it, and the reason why is you guys are going to use that to help write an equation. Remember that the first one is the sine of an angle is equal to the opposite over the hypotenuse. So O means opposite. I just spelled that, I'm sorry. Don't worry about it. H means hypotenuse. And A means adjacent. Now keep in mind, does everybody see in this picture right here, the angle that they're giving us is this one, that's 30-degree angle. I need you to understand, that angle that you're referring to determines which side is the opposite and which side is the adjacent, okay? Everybody, the 90-degree angle would be right here, okay? On the opposite side of the 90-degree angle is where the hypotenuse is always. So make sure you have that all labeled, okay? And I'll give you a minute to label that all. You're focused. All right. What we're going to be doing right now is we're going to prove that you can use sine, cosine, and tangent. And does everybody realize you know all three side lengths? You know what they all measure? And you have two angles, the 90-degree angle, this 30-degree angle, and you see there's an angle that's missing? That one measures 60. 60 plus 30 plus 90 should add up to equal 180. That's how I figured it out. I just took away the 5 from 180 and leaves me with 60 only. Okay. Now I haven't touched or done anything to label that angle yet, and the reason why is if you refer to this angle instead, that changes your opposite and adjacent if that's the angle you're going to use. So keep that in mind, okay? So if you do put that, keep that in mind that does change your opposite and adjacent, okay? So from there, this becomes the opposite if I'm using the 60-degree angle, okay? Then this side becomes the adjacent if you're referring to the 60-degree angle, okay? We're not going to use the 60-degree angle, okay? We're going to use the 30, okay? All right. So sine is this symbol right there. Does anybody remember the name that I said I'm going to refer to it? No? Okay, it's a Greek symbol, theta. Theta, okay? Greek symbol, okay? Theta. That theta is supposed to represent the angle measurement that you're using, okay? You're never going to use the 90-degree angle. It's the other two angles. The 90-degree angle is as a reference that's why you can use sine, cosine, or angle, okay? If it's not a right triangle, which I've already shown you how to do, how to figure out if a triangle is a right triangle. If it's not a right triangle, you can't use sine, cosine, or tangent to get any of the angles or sums. Okay, so 90 degrees has to be a right triangle. It has to be a right triangle for you to use this. Okay. Right. All right. So if you use sine, that means you have the angle measurement or one of the two sides, the opposite or hypotenuse, and you can find one of those three that's missing, okay? If you have cosine, cosine of the angle is equal to the adjacent over the hypotenuse. All right, and then the other one is TOA, and that's tangent of an angle is equal to the opposite over the adjacent. Now I've already labeled what the O, the H, and the A represent, okay? All right. Excuse me. All right, so we're going to do the sine of 30 degrees, okay? Now, first thing we got to do is we got to set up the equation. So go ahead and set up. Sine of 30 degrees is equal to which number represents the opposite of that angle? 1. And which number represents the hypotenuse? 2. All right, stop me right there. Right here?
30% of degrees. It's an equal sign, right?
Oh, right here, yes. That's an equal sign. Sorry about that. So that's sine of the angle that we're given. That's the 30 degrees. And the opposite side is the one that's 1. The hypotenuse is 2. Okay? So what you're going to do with your calculators now is you're going to check. So go ahead and type in on your calculators. Turn it on first of all.
Are we doing one?
Yeah, we're going to do sine first. Now, first thing real quick, we got to make sure we are all in the correct mode. So do me a favor, check mode, and that degree is highlighted, not radians. Okay? If you have radians highlighted, it'll look like this. If you have radians highlighted, it'll look like that. We don't want radians highlighted. We want degrees highlighted. Okay? So you scroll over to degrees and then hit enter, and now radians should be unmarked. Yes? That part, you guys got to get in the habit of always checking when you're doing work, whether it's on a test or you're just finishing some work from this unit, that you have to be in that mode. Okay? All right. So now we can go ahead and hit clear now. And we're going to type in sine, so sin, sine of 30. So sine of 30, close the parentheses and hit enter. 25, okay. Go ahead and hit 1 divided by 2. All right, you guys agree we get the same decimal value for both of them? So what I want you to do here is sine of 30 degrees is 0.5. And 1 divided by 2 is 0.5. Does everybody agree that those two numbers are the exact same? So just be patient. What you just did is, if you know the angle, you can find one of the two sides that is missing depending on if you use sine, cosine, or tangent. We already know all the sides, and we know all the angles. We're just checking so I can prove to you. This can work. If I know the angle, and I'm missing the opposite, but I have the hypotenuse, I can find the hypotenuse by solving this equation. Okay? The sine of the 30-degree angle is 0.5, which is the same as saying 1 divided by 2, which is the opposite over the hypotenuse. Okay? Now we're going to check, does cosine do the same? All right? We're still going to use 30. Okay? So now let's write cosine of 30. Cosine of 30, cosine is what? A over H. So what number is it? So what number is adjacent? Now we're not going to use 1.732. We're going to use the square root of 3. Okay. And the reason why we want to use square root of 3 is because square root of 3, if you type it in on the calculator, is that decimal value.
It has a better result.
Yes, that's perfect. I need the most exact possible answer, or number possible. Square root of 3 would be the better one instead of an estimated decimal. Yeah. So square root of 3 is the adjacent, yes? Which one is the hypotenuse? 2. Okay, so I'm just going to write square root of 3 over 2. Right, now we're going to check with our calculator, okay? Go ahead and type cosine of 30. And hit enter. You can close that parentheses, hit enter, and you got a decimal, the same decimal as I have? Yeah? Everything there? All right. Now we're going to check. Does square root of 3 divided by 2 give me that same decimal? So be very careful when you're working with the square root symbol, okay? Everybody see how to put the square root symbol on the screen? Hit the second button. And then look for the x squared button, because right above it in blue is the square root symbol. Are you getting that symbol on your screen now? Yep. Okay. In there, the only thing you want in there is the 3, right? Make sure you put the 3, and then you see the arrow is blinking, and it wants you to put more inside the square root. We don't want anything else, so go out of it. Now you can go ahead and hit divided by 2. And what that's saying is square root of 3 divided by 2. And you see we get the same number. Now I want to show you where somebody could have made a mistake. They would have done this. They would have done square root of 3, and then they hit divided by 2. You see that both, you're writing both of the things inside the square root, and the number's not going to be the same. And somebody's going to say, well, they're not the same. Well, it's because you wrote it wrong. Yeah. But does everybody agree that cosine of 30 is 0.8, what was it? 6. So I'll put 660. And that was equal to the exact same decimal when I get square root of 3. And hey, did I prove to you guys that those numbers were identical? Yeah. So now, do you see that the numbers I'm using with cosine, the decimal values, are different than the decimal values when I used sine? All that's doing is you got 3 different possibilities to figure out either the side length that's missing or an angle length that you're trying to solve. Okay? All right. So we just checked sine works, cosine works. Okay? Now let's check tangent. Tangent of what? 30. Still same angle. Equal to what? Opposite over adjacent, so what number would be the opposite? 1 over square root of 3. Don't use the decimal value. It'll give you a better answer if you put the square root in, okay? All right, so now we're typing tangent of 30. Notice the decimal values for sine of 30, cosine of 30, and tangent of 30 are all different decimal numbers. But remember, to check tangent of 30, you have to do 1 divided by square root of 30. Okay? So now hit 1. When you hit divided by, you can use a parentheses if you want. Square root of 3, and then get out of the square root symbol. Okay? Everybody okay right there? Yep.
It's like a math, you're just gonna hit number.
Right. Everybody agree we got the exact decimal value? Yep. All right. So what I'm doing then is I'm showing you 0.577. I'm going to say 0.5774. Is equal to 0.5774. Now, does everybody understand? I just rounded it off right now. This was 3. It was 0.57735, right? So I just rounded it up. Does that make sense? Yeah. Don't round off at the beginning. Round off at the very end when you're comparing them. Okay. No. I just wanted to make sure that I proved to you I get the exact identical decimal all the way through when I show it to you on the screen. Yep. Okay. Remember when we were checking if figures were similar, they had to be identical all the way through the decimal. They couldn't be off after maybe 3 or 4 numbers after the decimal, because that would then say, no, they're not similar when I check the proportion. Okay? All right. So what we just did right now is we checked sine, cosine, and tangent for this figure, which we know all the information. We don't need to find any of those side lengths or any of the angles. But this is what sine, cosine, and tangent do. They can help you find an angle if it's missing, but you need to know 2 sides at least. If you know the opposite and the adjacent, then you're going to use tangent. If you know the opposite and the hypotenuse, then you're going to use sine. If you know the adjacent and the hypotenuse, then you use cosine. So you don't know which one of these 3 you're going to use yet until you see what information you're given. Okay? All right. All right. Any questions on that first one right there? No? All right. So everybody understand sine, cosine, and tangent, how you're going to set up an equation. The Greek symbol theta is to represent the angle that you're using. Okay? All right. Let's go to the next one then. So we're going to do the same thing on the next one. Okay? All right. We're going to do the sine, cosine, and tangent of this angle. Can everybody set up the sine for me on your own with all of the information inputted? It does help some students to write out sohcahtoa again. If you write sohcahtoa incorrectly with a letter misplaced in the wrong spot, that will mess it up, okay? So it has to be spelled S-O-H-C-A-H-and-T-O-A, okay? Right? Who can help me here? How do I write sine? Michael, you want to do that one? Sine of what? Sine of angle 45, that's the one we're given right there, yeah? Equal to 1, that's the opposite of that angle, yes? 1 over square root of 2, perfect. All right, did everybody set up that correctly like that? Okay, now go ahead and use your calculators.
I got
and-
45.
All right, but did you get these numbers off then?
No.
No, okay. You gotta get those right, okay? All right, so now type in sin of 45.
I got 47 so 106.
All right, same number I'm getting? All right. Now go ahead and do 1 divided by square root of 2. We gotta get that exact same decimal. If it doesn't match, then something didn't come out. All right, so here's my 1 divided by square root of 2. Are you able to input that on your calculator the same? Okay, go ahead and hit enter. And you guys agree identical all the way through?
Yeah.
Yeah, okay. Go ahead and put 0.7071 equal to itself. We just showed it on the calculator. And what you just did is you proved that if you use sine and you have the angle and the two sides that go with it, you get the same value on both sides. Okay. Go ahead and set up cosine now. Set up cosine. All right, so we just did the cosine, we did the sine of the opposite, which was 5, over the hypotenuse, which was 13. And we're trying to get the angle measurement. Once we get this part set up, the angle, which is labeled as, that symbol represents what is called Greek word beta, okay? That symbol, we're going to find the angle measurement of it as sine to the minus 1 over 513. But I want you guys to start referring to it as sine inverse, okay? Say sine inverse, cosine inverse, and tangent inverse, okay? So that's how I'm going to say it, okay? And then cosine of an angle is equal to the adjacent over the hypotenuse. So we had to find out the angle by using cosine inverse. Yes? So now I'm going to show you what tangent inverse would look like, okay? Tangent of a theta is equal to the opposite, which is 5, over the adjacent, which is 12. So to figure out the angle measurement for theta,
Extra charger.
theta then is equal to tangent inverse of 5 over 12. Can everybody type in tangent inverse of 5 over 12 on your calculator for me? Yeah, we're still problem number 5. And we need a tangent inverse. Let me start. Oh, I'm sorry.
Opposite adjacent lines.
Oh, they are different numbers. Yeah. Oh, I see what you're doing. I see what you said. I did a tangent of number 5, but I set up tangent of number 4. I'll go ahead and do both of them. Okay. I didn't catch that. So tangent of inverse of 5 over 12 will be for number 4. So in your notes, make sure that is for number 4. And I'll do number 5 in a second. Okay.
My answer is 23.
Okay, so 5 over
I got this.
12. Same thing when you're getting? Oh wait, something's wrong on my screen. It's not inverse. I wrote just tangent.
Yeah,
Okay. All right. So I got to make sure I did the second tangent inverse. Yes, I didn't have tangent inverse. It's the same number. All right. So 5 divided by 12. Close the parentheses and enter. I still get the 22.62 for problem number 4 as I did when I did sine. Yes. Okay. All right, so now I'm going to do number 5 then. So I'm going to do number 5 with tangent. Tangent is opposite over adjacent. Now, Evan, remember how you were telling me you're having trouble figuring out which one's the opposite and which one is the adjacent, right? Make sure you go, which angle are they asking you, and then right away, draw a line to the side that's opposite, and label that as your opposite. Okay. Here's the 90-degree symbol, right? This is your hypotenuse. The only thing that's left is the side that would be labeled adjacent, okay? Right. So this is tangent of the angle is equal to 3/6. So now you're going to do theta is tangent inverse of 3/6. So go ahead and type in tangent inverse 3/6. Are you guys getting 26 going on with that? Okay. Everything? And if you round it off to the nearest 100, we would say what? 0.57. Sorry. So theta is equal to 26.7 approximately. Okay. That was page 2. Page 2. Oh. That kind of threw it off a little bit, but it was, I kind of wrote it on there, so it kind of makes it look weird. Okay. All right. Are you guys getting the idea? Because this was a very good question that you asked. Well, what's the purpose of using sine, cosine, and tangent? Yeah. And it's because sometimes you're going to only have some sides given. Yeah. Okay. All right. All right, you're going to do that on your own. We'll do that on next time, okay? All right, so here's what's left. You guys are going to read through this. You're going to read through the next page. Everybody get to the next page. You're going to read through that. You're going to look and read through the examples. Make sure you understand the wording that's being used, okay? You're going to read through that. There are examples that are going to be given, and I want you to read through them to understand them, okay? You're going to understand up to those examples, and then you're going to go all the way to these practice problems, and you're going to work those problems out. You are going to have to do some drawings. Okay? The drawings are going to be very simple. They've got to have a right triangle in them. Okay? Right. And you're going to answer these questions, numbers 1 through 10. Okay? 1 through 10. Once you get through 10 and you see where the challenge problems come, stop right there. I don't want you to work on those. Okay? Don't work on the challenge problems. Those are going to be for next class, okay? You guys can work together with each other to help each other out. You can come to me if you get stuck because you're like, I don't know what to set up. And that's where I can help you one-on-one. Yes? All right. I'm going to be playing some music. So you guys, your volume should be less than the volume of my music. Yes? All right. When you finish to number 10, come and show me your work, and then you can leave. Some of you guys are faster than others. Help each other out. Okay? Slow. All right.